All right, we're going to take a look at 8-1 sequences. Um, Throughout this whole chapter, we're going to be dealing with sequences and series, so I just want to really use 8-1 as a introduction or a review of what you already know about sequences and series. And then there is some discussion in the section 8-1 that I'm not going to go over. You can read through if you want, but we're going to really pick up that stuff as we go through this chapter. So if you pay attention or take notes on what I'm getting ready to do, that'll help you with the homework tonight and allow you to know what kind of things I expect you to know from 8-1. Basically, we're just reviewing what you already know about sequences. By the way, a difference between a sequence and a series. A sequence is a list of numbers or a list of something separated by commas. A series would take that sequence and you add them together. And that's what a series is. But let's just jump straight in and look at some homework. So page 564 is where the homework is out of, and it says things like find the first 5 terms of a sequence when given a formula. We call this formula an explicit formula, and it's based on the nth term. So what I'm asking for the first 5, I'm looking for a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. That would be the first 5 terms. It's as easy as it looks. You just plug in for the first term 1 for n, 1 plus 3. Second term 2 for n, then 3, and so on. And you just figure out what those would be. In this case, it's 2 over 4, which reduces to 1/2, 4 over 5, 6 over 6, which reduces to 1, 8 over 7, and 10 over 8, which reduces to 5/4. A lot of times it's easier to see what's going on in the unreduced form, because if I had to base this on the second numbers here, try to figure out what's going on if I was going from this sequence, 1/2, 4/5, 1, 8, 7, 5/4, it'd be harder to kind of come up with a rule for it. But if you look at the second number, 2/4, 4/5, 6, 6, 8, 7, 10, 6, it's obvious that the top numbers are the even numbers, while the bottom numbers are just adding 1 to it each time, start with 4. So we're going to do that as well. But the first and the easiest problems are just come up with a number in the sequence based on an explicit formula. Well, this one is an interesting one because it is oscillating, alternating series is what we call it. And anytime you take a -1 to the nth, it'll change the sign. So let's look at what I mean by that. If I look at a sub 1, then that's -1 to the 1 plus 1 over 2 over 1, putting in 1 for n. -1 squared is a +1, so this answer is just 2. But now when I do a sub 2, I got -1 to the 2 plus 1, which is now an odd one, so it's going to make that -1 over 2 over 2. So basically we have -1 times 1, or -1. The third one, -1 to the 3 plus 1 over 2/3. 3 plus 1 is an even number. -1 an even number is a positive, so this is 2/3. And a sub 4 is equal to -1 to the 4 plus 1 over 2 over 4, which is negative because this is now odd. 2/4 is 1/2. And a sub 5 is -1 to the 5 plus 1, which is an even number, making it positive over 2, 5, so it's 2/5. Oh, sorry. Is that right? Yeah, 2/5. What you may notice is the fact that it alternates. So this is positive, this is negative, this is positive, this is negative. So that's why it's called the alternating series, or sequence in this case. All right, other types of problems we have is recursive, and recursive defines it based on the previous term. So you can describe a sequence or series in 2 ways. You could describe it explicitly based on the nth term, or recursively based on the previous term. So to find the first 5 terms, I already have first term here. So I'm looking for the second, third, fourth, and fifth term. Well, this recursive formula says that the next term, a to 2, which is a to the 1 plus 1, so in this case, my k is 1, would be 1 plus 1 divided by 2 times the previous term, which is 4, a sub 1, because we're looking for a sub 2. So that's equal to 2 over 2 is 1 times 4 is 4. So if I'm going a sub 3, that's 2 plus 1, by the way. So I'm looking at the term right before it. So my k is now 2 from before, plus 1 over 2, times the value I got before, which was 4 as well. So now we have 2 plus 1 is 3. 2 plus 1 is 3 divided times 4, so 3/2 times 4 is going to be 6. Do another one. A sub 4 is equal to a sub 3 plus 1, or the previous term. So it's 3 plus 1 over 2 times the previous answer was 6. So 4/2 is 2. 2 times 6 is 12. And finally, the fifth term would be fourth term plus 1. So now we have 4 plus 1 over 2 times that 12, which is 5/2 times 12, which is 6 times 5 is 30. And that's using a recursive formula. Well, an important set of problems on this is actually simplified factorials, which seems to not have anything to do with what we're doing, but it does come up a bunch during this chapter, so I want to talk about it. You know that a factorial or n factorial says you just take one less than the term each time until you get down to 1 and you're multiplying it. So 25 factorial is 25 times 24 times 23 all the way down to 1. And 23 factorial would be 23 times 22 times 21 all the way down to 1. Probably a better way to write that is to say that 25 factorial is 25 times 24 times 23 all the way down to 1 is actually 23 factorial over 23 factorial, and those will cancel out. So the answer is whatever 25 times 24 is. And I'll let you finish that. All right, simplifying in general then, n plus 2 is n plus 2 factorial over n factorial is n plus 2 times reduce it by 1, n plus 1 times reduce it by 1, n all the way down to 1, or else we can call that n factorial, all over n factorial. Very similar to what we did down on the numerical one. N factorials cancel out, and this simplifies n plus 2 times n plus 1, and you can leave your answer like that. All right, to find out where these sequences are going, we're actually finding the limit of the sequence. So I could look at what happens when this is starting with 1. This starts at 4. When I put a 2 in there, now I'm subtracting 1/4 from 5. And then when you can see that it's this is getting smaller and smaller. This part is getting smaller and smaller as n gets larger. So you can kind of guess that this is probably going towards 5. But that's exactly what you're talking about. We're talking about as n gets very large, or as n approaches infinity, what 5 minus 1 over n squared will tell me where this actual sequence is heading. Well, I'm evaluating this 1 over infinity, which we have determined is 1 over infinity is 0, and 5 minus 0 is simply 5. So this sequence is converging on 5. It's divergent if it's going off to infinity, or negative infinity, or as we'll see, some other circumstances that create divergent sequences. All right, so once again, this limit, this sequence is the limit as n approaches infinity. We're only concerned with the leading term, so the square root of n squared is n. So this one is heading to 5 as well. That's number 38. All right, convergence. Convergence is the same as finding limits. It's just saying if it's not heading towards infinity, then what number is that? So I have to talk about the limit as this approaches -1 to the n. It might be a good idea to look at several terms to kind of decide where this is heading. So if it's 1 plus -1 to the first power would be -1, so that's heading to 0. A to the 2 is 1 plus, now that's a positive number, it's 2. A to the 3 is 1 plus negative power is -1 is 0. And I think you can see what this sequence is going to do. Because it's oscillating back and forth, we say it diverges. That it's not heading towards any one number. It depends on where you're looking at, specifically on what number it is. So that would not converge. All right, next one is this one. And you do it like a limit. The limit as n approaches infinity, as the cube root of n, we're only concerned with the leading term, cube root of n is obviously heading to 1, so we say it converges at 1. All right. Probably the hardest ones to explain is to come up with a formula. Recursive is actually easier to come up with because you base it on the previous term. So if I say that let a sub 1 equal 3, I'm doing this recursively first, and it looks to me like I would add 3 each time. So if my a sub n would be whatever my previous one would be, a sub 1 n minus 1, I said 3, but you add 4 each time. So that is a recursive formula. It says take the previous term and add 4 to it. Harder to come up with is explicit. And you kind of can do trial and error on these. You want to find something that I can base it on terms. So if you look at the terms, 1, 2, 3, 4, and kind of try to determine it from here. Now it looks to me like if I start with 3, and then if I put in, I have to go to n minus 1 times that 4. So if I go n minus 1, let's see if that works. 1 minus 1 is 0. That's why I did the n minus 1 times 4 is 0, so it's 3. That worked. If I put a 2 in here now for n, I get 2 minus 1 times 4 plus 3 is 3 plus 4, which is 7. And you can see that I did come up with the right formula. Now you can simplify that to 3 plus 4n minus 4, which is 4n minus 1 will give you. A lot of times that's trial and error. With this is actually, if you recall, arithmetic, and it's your starting place plus n minus 1 times your constant difference. We'll talk more about that kind of stuff. With those, I just want you to trial and error. So basically what I want you to do tonight is just review this kind of sequence and series, and then we're going to start some calculus with it starting tomorrow. Thank you.